Good day, grade 9 students. In this video, you will learn the nature of the roots of a quadratic equations. Our objective is to characterize the roots of a quadratic equation using the discriminant. Alright, let us begin with a review of writing the quadratic equation into standard form ax squared plus bx plus c. And let us identify the values of a, b, and c. Let us have number 1. 2x squared is equal to x minus 1. In standard form, it is written as 2x squared minus x plus 1 is equal to 0, where the values of a is equal to 2, b is negative 1, and c is 1. Next, we have number 2. 5y times the quantity y minus 3 is equal to 0. It will become 5y squared minus 15y is equal to 0. Where a is equal to 5, b is equal to negative 15, and c is 0. Next, number 3, we have 11x squared is equal to 0. This given equation is already written in the standard form. So let us just copy in the second column, where a is equal to 11, b is equal to 0, and c is also equal to 0. Then number 4, 10m squared is equal to negative 3. By addition property of equality, this will become 10m squared plus 3 is equal to 0, where a is equal to 10, b is equal to 0, and c is equal to 3. Lastly, we have quantity x plus 3 times the quantity x plus 5 is equal to 0. After multiplying the expression on the left side, it will give us x squared plus 8x plus 15 is equal to 0, where a is equal to 1, b is equal to 8, and lastly c is equal to 15. Before we proceed to the main lesson, let us have a quick review on the number system. From complex numbers, we have the real numbers and imaginary numbers. From real numbers, it is divided as rational numbers and irrational numbers. From rational numbers, we have the fractions, whole numbers, negative numbers, 0, terminating decimals, non-terminating but repeating decimals, square root of perfect squared numbers. In irrational numbers, we have the square root of non-perfect squared numbers, like square root of 31, square root of 11, and square root of 22. In imaginary numbers, we have the square root of negative numbers because those are numbers that does not have a tangible values. Previously, we have discussed the quadratic formula, which is x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. In this formula, b squared minus 4ac is the discriminant of the quadratic equations. It is used to characterize the roots of the quadratic equations. To characterize the roots of the quadratic equations, we have 4 cases to consider. The first one, if d is equal to 0, the nature of the roots are real, rational, and equal. Next, we have d is greater than 0. The discriminant is positive and a perfect square. The roots are real, rational, and unequal. Next, we have d is greater than 0, but the value is positive and not a perfect square. The roots are real, irrational, and unequal. And then lastly, if the value of d is less than 0, that is the discriminant is negative, the nature of the roots are imaginary. To guide you, let us follow these steps in finding the value of the discriminant. First, write the quadratic equation in the form ax squared plus bx plus c is equal to 0. Second step, identify the value of a, b, and c. Third, substitute the values to b squared minus 4ac. And then lastly, evaluate the values. Now let us have some illustrative examples. Number 1, Find the nature of the roots of x squared minus 12x plus 36 is equal to 0. As you notice, our equation is already written in the standard form. So we can now proceed in finding the value of a, b, and c. So our a is equal to 1, our b is equal to negative 12, and our c is equal to 36. Now, let us substitute those values in the discriminant b squared minus 4ac. So our b is negative 12, so that is quantity 12 raised to 2 minus 4 times 1 times 36 because your a is 1 and then your c is 36. Now let us evaluate the values. Quantity negative 12 squared is equal to 144. Negative 4 times 1 times 36 is negative 144. 144 minus 144 is equal to 0. That means our discriminant is equal to 0. Going back to the table of cases of discriminant, if it is equal to 0, the roots are real, rational, and equal. Hence, the nature of the roots are real, rational, and equal. Next, number 2. Find the nature of the roots of x squared minus x is equal to 12. As you notice, this equation is not written in the standard form. So we need to write this in the standard form. And that is x squared minus x minus 12 is equal to 0, where a is equal to 1, b is equal to negative 1, and c is equal to negative 12. Then let us substitute these values to the discriminant b squared minus 4ac, and then that is quantity negative 1 squared minus 4 times 1 times negative 12. Quantity negative 1 squared is equal to 1. Negative 4 times 1 times negative 12 is equal to positive 48. So that is 1 plus 48, which is equal to 49. So our discriminant is equal to 49. In the table of discriminant, 49 is positive in a perfect square. Therefore, the nature of the roots are real, rational, and unequal. Hence, the nature of the roots are real, rational, and unequal. Next, number 3. Find the nature of the roots of x squared minus 2x is equal to 5. The same with number 2. This is not written in the standard form. So we need to rewrite this again in the standard form. And that is x squared minus 2x minus 5 is equal to 0. Where a is equal to 1, our b is negative 2, and c is equal to negative 5. Then let us substitute these values to the discriminant b squared minus 4ac, and that is equal to the quantity negative 2 squared minus 4 times 1 times negative 5. Quantity negative 2 squared is equal to 4. And then negative 4 times 1 times negative 5, that is positive 20. And then 4 plus 20 is equal to 24. So our discriminant is 24. In the cases of the discriminant, 24 is positive and not a perfect square, and the nature of the roots are real, irrational, and unequal. Hence, the nature of the roots are real, irrational, and unequal. Next, number 4, find the nature of the roots of 2x squared is equal to x minus 3. In standard form, it is written as 2x squared minus x plus 3 is equal to 0, where a is equal to 2, b is equal to negative 1, and c is equal to 3. Let us substitute these values to the discriminant b squared minus 4ac, and that is equal to quantity negative 1 squared minus 4 times 2 times 3. Quantity negative 1 squared is equal to 1, and then negative 4 times 2 times 3 is equal to negative 24. 1 minus 24 is negative 23. So our discriminant is negative 23. Going back to the cases of the discriminant, negative 23 is negative, and then the nature of the roots are imaginary. Hence, the nature of the roots are imaginary.